Hi guys, so today we're going to be learning about congruent triangles. Now before I start, I'm going to be teaching you some terms I'm going to be using throughout this lesson. So here goes. So the first term or symbol is this. Now, whoa, what is this? It's a squiggly line with an equal sign on the bottom. Now this means congruent. Congruent means exactly the same. So if two angles are congruent to each other, that means they have the same degree. If two sides are congruent to each other, that means they have the same length. The second term is called corresponding. Now, corresponding is a bit hard to explain, so I'm going to draw it out for you. So, let's say I have these two triangles. If I say that this side that I marked with one tick mark, is corresponding to this side, they're on the same side, get it? So I'll be marking corresponding sides with these tick marks. So if this has 3 tick marks and the other triangle has 3 tick marks, that means they're corresponding. You get the point. So let's move on. So what are congruent triangles? Well, congruent triangles, here, let me draw it out for you. If I give you 2 triangles, let's label them A, B, C, D, E, F. Now, if I say that these 2 triangles are congruent to each other, then their 3 corresponding sides have to be the same. They have to be congruent to each other. So let's say this one tick mark side is 3. Then this one also has to be 3. Now, another part of congruent triangles is that these 3 angles have to be congruent to each other. So BAC, this angle, would be congruent to EDF. Get it? So I'm also going to be marking the 3 triangles with tick marks. Okay, so this means that these 2 triangles are congruent with each other. Now, there are also different ways, they're called theorems, to prove that 2 triangles are congruent to each other. So the first theorem is called SSS. Now, what's SSS? SSS means side, side, side. So if you're given 2 triangles, and we tell you that these 3 triangles have correspondingly congruent sides, so all the corresponding sides are congruent to each other, then you can say by the theorem of SSS that these 2 triangles are exactly the same, or congruent. The second theorem is called SAS. So SAS means side, angle, side. So if I give you 2 triangles again, but I don't tell you if all 3 sides are congruent, I only tell you that 2 corresponding sides are congruent. If I only give you 2, you cannot say that the third side is congruent to each other because you never know, because we didn't tell you that. But I do give you that this angle is congruent to each other. Notice the formation of the letters. The A is between the 2 S. So see how also like this angle is in between the 2 sides? This is called the included angle. So it's in the middle of 2 sides. So if you want to prove the theorem SAS, the angle has to be in the middle. It has to be the included angle of 2 sides. If I give you this, then you can also say that these 2 triangles are congruent to each other. The third theorem is called ASA. So you get the idea. It means A, angle, side, angle. So here, if I give you 2 triangles again, and I give you that 2 angles are correspondingly congruent, and I also give you the included side. So S is in the middle this time, so it has to be in the middle of these 2 angles. Then these 2 triangles are also congruent. Now the fourth theorem is called AAS. So you know that this means angle, angle, side. Now, okay, backtrack and ask yourself, what's the difference between AAS and ASA? Okay, so notice the formation of the letters or the ordering of the letters is different. If the ordering is different, then the theorem is also different. So here, let's compare to the theorem above. So I give you these two triangles. And I give you that these two corresponding angles are congruent to each other. And I give you that this side is also congruent to each other. Then by the theorem of AAS, these two triangles are congruent. Notice that it's not the included side, because if it was the included side, it would not be called AAS, it would be called ASA. The fifth theorem is called HL. Okay, remember this. HL only works with right triangles. So right triangles are triangles with a right triangle, a 90-degree angle. Okay, so HL, let's say we have two right triangles. And H means hypotenuse, which is the longest side, and L means leg, so any other side other than the hypotenuse. If I say that these two hypotenuse is congruent to each other, and another corresponding leg is congruent to each other, I can say that these two right triangles are the same right triangle. They're congruent to each other. Now, there are also rules to this theorem. I know that there are different formations of the letters make different theorems, but remember, okay, the theorem ASS does not exist. Do not laugh. ASS does not exist. Also remember, SSA doesn't exist either. Okay, if I give you, okay, I'm going to draw it really small over here. If I give you two triangles and I give you one angle, and this side is congruent to each other, and for SSA, the same thing, it does not mean that these two triangles are congruent. ASS and SSA do not work. Okay.